Part 3, Solving Inequalities. Use a sign line to solve 3x squared plus 5x is less than 2. I will start by getting everything on one side and 0 on the other side of my inequality. And then I can factor this. This is 3x minus 1 and x plus 2 less than 0. So 3x minus 1 equals 0 when x is 1/3, and x plus 2 equals 0 when x is negative 2. So negative 2 and 1/3 are the numbers on my number line. Now I can use a sign line and test different values in each of my intervals. Another option, if you want to do that, is I know that this is a parabola that opens up, so I know it will look something like that, passing through negative 2 and 1/3. So where is this less than 0? Well, between negative 2 and 1/3. We could also test values. Plug in a number between negative 2 and 1/3 would be like 0. If we plug in 0, we get a negative number. If I plug in a number bigger than 1/3, I would get positive. If I plug in a number less than negative 2, I would get positive. So if you know what the graph looks like, you don't necessarily have to do the sign line. You can just think about the graph. Let's try this one. If I get everything on one side, I have x cubed minus 7x squared plus 7x plus 15 greater than or equal to 0. So this one doesn't factor easily, but we can find our possible rational zeros, which would be the factors of 15 divided by the factors of 1. And negative 1 actually works. You can verify that if you'd like by plugging in negative 1. But when I do the synthetic division, we'll see we do get a remainder of 0. So I'm going to do that synthetic division. And our remainder is 0. So if I were to factor this, so far I would have x minus a negative 1, or x plus 1. And I'd be left with x squared minus 8x plus 15. And I can factor that to x minus 3 and x minus 5. And we have greater than or equal to 0. So my zeros of that polynomial are negative 1, 3, and 5. And I could graph this or use the sign line and plug in numbers on my different intervals. So this time let's plug in some numbers. If I plug in a number bigger than 5, say 6, I would get 7 times 3 times 1, which is positive. Between 3 and 5, let's say we plug in 4, then I would get 4 plus 1 is 5 times 1 times negative 1, which is negative. And because all of my factors have an odd multiplicity, I do know it's going to go back and forth between positive and negative. So I want where we're greater than or equal to 0, which would be negative 1 to 3. And then it's positive again after 5. And because it says greater than or equal to, we're using brackets to include these zeros. Find the domain of f of x equals the square root of x squared minus 4. We know that whatever we are taking the square root of must be greater than or equal to 0, because we cannot take a square root of a negative number. If I factor this, I get x plus 2 times x minus 2 greater than or equal to 0. So my zeros of this function are 2 and negative 2. And x squared minus 4 is a parabola that opens up, so we know it will look something like that. We want to know where it's greater than or equal to 0. That would be from negative infinity to negative 2. And again from 2 to infinity. So you could plug in numbers in the different intervals, but if you know what the graph looks like, we don't need to find the vertex of this parabola or anything, just a really rough sketch, just enough to know where it's positive and where it's negative. The height h in feet of a ball above the ground, t seconds after being tossed into the air, is given by this function right here. H of t equals negative 16t squared plus 96t. For what interval of time is the ball more than 128 feet above the ground? So where is this function greater than 128? We want more than 128. So to solve this inequality, I will get everything on one side. So I have 0 on the other side of the inequality. Then I can factor out a negative 16, and I would get t squared minus 6t plus 8 greater than 0. So negative 16 times t minus 2 and t minus 4. So my zeros of this function now are 2 and 4. Now I know I have a parabola that opens down because my leading coefficient, -16, opens down. I can also plug in some different numbers. Let's plug in 5. If I plug in 5, I get -16 times 3 times 1, which is negative. So it's negative to the right of 4. If I plug in a number between 2 and 4, say 3, I would get -16 times 1 times -1. Negative times negative makes it positive. And then a number less than 2, say 0. 0 is an easy number. Then I would get -16 times -2 times -4. So 3 negatives make it negative on that side. So whether you graph or you plug in numbers in the different intervals is completely up to you. I want to know where we're greater than 0, which is between 2 and 4. So the answer to the question for what interval of time is the ball more than 128 feet above the ground would be between 2 seconds and 4 seconds.